Office Tower Floor Plan Analysis. Zephyrah is a software that helps in stage analysis of energy-efficient building design. For this specific analysis, we used Torre Bansi, an office building designed by Alberto Kalach in Guadalajara, Jalisco. The first step was to model the building in SketchUp using only paper-thin materials. In this case, we had 33 floors of 50 by 20 meters with a total area of 33,000 square meters. After that, we needed to assign materials with the Zephyrah plugin. We determined what was considered external wall, internal wall, and fixed glazing. Once we uploaded our model to the Zephyrah webpage, we had to start determining a baseline, which helped to set up the basic characteristics of the building. We adjusted the envelope, glazing, walls, floors, infiltration, and roof assembly, and afterwards used that baseline to make 4 clones. Those were the ones where we made some iterations to understand the development of the building under different circumstances. For all these clones, we also analyzed the energy breakdown circle, and we focused on the cooling section, because this is the one most affected by the glazing and solar aspects of the building. The first clone was the one of facade glazing, where we selected the south facade and started calculating the solar heat gain coefficient response curve. For example, in this curve, we were able to understand how the building is working in its energy use intensity, EUI, depending on the SHGC. When the coefficient is lower, the energy is also low, and when the coefficient is higher, the energy use will also increase. On the second clone, we focused on override glazing ratio, taking into account the window-to-wall ratio. This response curve performs in a similar way to the one of solar heat gain coefficient. If you have a bigger ratio, the EUI will be higher. In the third clone, we analyzed the building orientation, calculating the EUI response curve when we rotate our building from -45 to 45 degrees. And finally, the last clone was focused on the software shading, where we used the horizontal shading tool. In this response curve, when you have a bigger coefficient of shading, correspondingly the energy use will be lower. At the end, we created a last clone to understand which strategies work best and how combining them will reduce the EUI compared to the baseline. We can understand and observe here how the baseline has an EUI of 167 and the final clone with these strategies finishing 152 kilowatts per square meter per year. This last image shows how the cooling is working in regards of the energy use.